Welcome back to Math 104. This is the beginning of video set number 5. This is a point in the course where some especially fun examples are called for. Right now we'll look at a certain game show called Deal or No Deal, and in fact we'll play an online simulation of it. This turns out to be a nice illustration of some ideas in probability. The setup of the game is that there are 26 closed briefcases, each containing one of the following amounts of money. You have no idea which amount of money is in each briefcase. You select one of these briefcases to be yours. Even so, you still do not know the amount of money inside it. One briefcase has been set aside, and the next thing you do is to select 6 of the remaining 25 briefcases. Those 6 are now opened, and their amounts revealed. What you now know is that those 6 amounts are no longer candidates to be the amount in your briefcase. Let's go to the simulation and see how this works. The first thing we do is select our briefcase. We have no basis for selecting one instead of another, so let's just pick 12 because it's right in the middle. One of these dollar amounts actually lives inside our briefcase. Next, we select 6 briefcases to be opened. Again, there's no particular reason to select one set of 6 briefcases instead of another, although people who play this game will feel passionately that it does matter. But let's see what happens. Let's open up number 1. Okay, so $750 is no longer the amount that could possibly be in our briefcase. And $50, okay. 1 cent. So this is all very good news. As the smaller amounts are taken out of contention, that means it is likelier, with each successive briefcase that's opened, this is good news. With each successive briefcase that's opened revealing a small amount, every time a small amount is taken out of contention, there is a greater likelihood that one of these very large amounts is the amount in our briefcase. We keep going. Okay, good news. Right, another small amount taken out of contention. And 200, okay, good news. And the 6th one, ooh, that hurts a little bit. There's still plenty of large amounts we could possibly have in our briefcase. And now we get a phone call from the banker. The banker is now offering us a certain amount of money to quit now. The banker would love for us to quit now. He doesn't want to take the risk that maybe $1 million is in our briefcase, or $750,000 is in our briefcase, or another large amount. So he offers us $16,000 to quit now. We can either say deal, in which case we get the $16,000, or no deal, in which case the game continues. Now we'll come back to this question of how you make your decision, but just think about what your initial reaction is. Intuitively, do you think it's worth continuing to play and possibly ending up with only $1, but possibly ending up with a very large amount? Or is it better to just take the guaranteed $16,000 and go home? Math alone cannot tell you the answer to this question, but it can shed a great deal of light on it. I can understand if your reaction is, 16,000? Are you kidding me? That's an insult. What do you think I am, that I would take 16,000 to quit now, when I could possibly win this much larger amount? No deal! Alright, we keep going. Now, at the next stage, we select only 5 cases to be removed. That is, 5 cases to be opened, and the amount revealed. Okay, $1. And $1,000. Great. Right, so I want to illustrate something now about the mathematics. From the start of this process, there was a certain experiment with 26 equally likely outcomes. The question is, which of these $26 amounts is the dollar amount in our briefcase? These are equally likely. So we can compute the expected amount, in the mathematical sense of expected, we can compute the expected amount of money in our briefcase. And what do you know? Here's a spreadsheet in which to do it. At the very start, if you average up these 26 amounts, you will obtain a little bit more than $131,000. Because these $26 amounts are equally likely, when we compute the expected value of the amount in our briefcase, what we're really doing is averaging up these 26 numbers. Or you could think of it by our second method as taking each of these numbers, multiplying it by 1 over 26, and adding them all up. Either way, the result is the same. These large amounts here have a substantial effect in pulling this average up, even though there's a large number of much smaller amounts. Now, as each briefcase is opened and a new dollar amount revealed, and therefore taken out of contention, it prompts us to redo the computation. So taking 1 cent out of contention and redoing the computation, which is now an average among 25 numbers, increases the average. Similarly, taking $1, $25, $50, taking these small amounts out of contention, 25, 50, these also raise the average. They also increase the expected value in light of this new information. Taking $300,000 out of the picture will decrease the expected value of what's in our briefcase. So the other amounts were $200, $750, and $1,000. So $200, $750, watch how that is going to make the average increase, and $1,000. Removing $1,000 will also increase the expected value of what's in our briefcase. Let's go back to opening some more briefcases. There are 3 more that need to be opened at this round. Right, so 500, 750,000, oh, that hurts. And then 11, oh, God, 200,000. All right, so the banker is going to call again. Before we see what the banker has to say, let's redo our computation here. $750,000 was taken out, 200,000 was taken out. All right, the expected value of what's in our briefcase is still well over $100,000. That means that if we took this scenario right now, with these dollar amounts still out there, still potentially the amount in our briefcase, if we repeated the experiment many, many times and waited to find out what was in our briefcase, then on average the amount in our briefcase would be $144-something thousand. That's if we repeated this process many, many times with these remaining amounts. So now let's see what the banker is offering us to quit now. The banker is offering $43,000. Okay, here's where you have to ask yourself a very personal question. Which would you rather have? The guaranteed $43,000 that the banker is willing to pay you right now if you'll just agree to quit, or the potential to make some much larger amount if you keep playing? The fact that the banker's offer of $43,000 is less than the expected value of what's in the briefcase is not quite enough, necessarily, to determine the conclusion that you should keep playing. Many people will keep playing, especially after they do this computation, but it's still possible that $43,000 will make a very big impact on your life right now, and you'd rather just have the guaranteed amount. Okay? Math cannot tell you whether it's better for you to take the guaranteed amount or to take a risk in order to make a larger amount. But the result of this computation is still some kind of a guideline. So let's say, no deal, let's keep playing. Now we open 4 cases just for variation. Let's start opening them from the other end. Let's open case 26. That takes 10,000 out of contention. Case 25 takes 25,000. Let's just see the effects of those. Removing 10,000 from contention and 25,000, those are smaller than the current expected value. So taking $10,000 out of the picture actually raises the expected value. Taking 25,000 raises the expected value. The relative likelihood of these very large amounts just got larger because smaller amounts were taken out of contention. Let's keep going 2 more cases. We open case 20. Oh, that is a disaster. All right, but let's see the effect. $1 million can no longer be the amount in our briefcase. Let's see the effect of removing it. It will certainly cause the expected value to drop, but let's see by how much. Okay, that is a very substantial drop. Oh, that's painful. Nonetheless, it's still more than the $43,000 the banker just offered us to quit. So let's keep going and see what the banker says next. Okay, right, so $5,000 just got taken out of contention. We redo our computation, right? Our expected value is back over 100,000. Right, let's see what the banker has to offer. Okay, this is getting to be a tougher choice. This is where you start finding things out about yourself, personally. Do you want to take the $77,000 the banker is offering, or do you want to keep playing and hold out for maybe a little bit more, 100,000, or a good bit more, 400,000 or 500,000, but you could very well end up going home with $5 or $10 if you keep playing. You've got $77,000 being offered to you right now. Think about what you would want to do, but I'm going to say no deal. Let's just see what happens. We're going to select 3 more cases to be removed. Right, 75,000 just got taken out of contention. Notice, this will actually make our expected value increase. We just removed a number from the average that was smaller than the average. Therefore, the new average is larger. Case 21 has $75 in it. Okay, that'll really increase the average. Okay, very nice. And 20. Case 20 contains $10. Okay, this is getting interesting. Not that many cases left. We could be in for a big payday. So let's see what the banker offers. $109,000. All right. I don't know about you. I am very tempted to quit here. I'm very tempted to take the $109,000. It's a little bit less than the expected value, and this is where we really see the contrast between the banker's perspective and our perspective. From the banker's point of view, this is a game that will be played many, many, many times over. And in the long run, the banker is better off lowballing you. The banker is better off trying to get you to accept a dollar amount that's less than the expected value, because even if our briefcase, whose contents the banker doesn't know any more than we know it, even if the contents of our briefcase should turn out to be only $5 or $100, from the banker's point of view, in the long run, from the banker's point of view, it's also possible that there's $500,000 in our briefcase, and in the long run it's better to get us to settle for an amount less than the expected value than to hold out and see what's really in the briefcase. From our point of view as players, however, it's a different perspective. From our point of view, we're playing the game once, or we can imagine if we're actually on this game show, we're playing only once. This is our big opportunity. And in light of the fact that this is our one chance to play, maybe it is better to just take the guaranteed $109,000. After all, it is guaranteed. While you're watching this, you make your decision what you want to do here. This is very nerve-wracking, but I'm going to go on. No deal. Let's see what happens. I'm going to pick lucky number 13 next. And it contains $100,000. It might seem that that hurts, but from an expected value point of view, that's still less than our current average. So removing $100,000 from the computation increases the average by a little bit. We have one more case to open before we get another offer from the banker. $50,000, okay. That also increases our expected value. Wow, this is really nerve-wracking. Okay, and the banker offers $143,000. All right. Think about what you want to do here. I'm going to take the deal. I'm just going to take the deal. Great. Now we find out, good thing we took the deal. It was only $300 actually in the briefcase. That's what we would have been left with if we'd kept on until the bitter end. The key point for us, as students of probability, is to realize that the practical mathematical question, how can you decide if the banker's offer is a good offer, involves expected value. There's an expected value computation embedded in the decision. I don't say that the expected value computation determines your decision, but it's certainly relevant to the decision. Let's write out a simple version of this computation. Suppose that we're playing Deal or No Deal, and there are 4 briefcases left, including our own. The 4 remaining amounts are $1,000, $25,000, $100,000, and $1 million. We can ask what is the expected value of the amount in your briefcase, in our briefcase at this stage. As of right now, an ideal dataset for this experiment consists of 4 outcomes with associated amounts $1,000, $25,000, $100,000, and $1 million. The computation is therefore just a job for averaging up these 4 numbers and seeing what we obtain. When we sum these up and divide by 4, we turn out to get $281,500. That is the expected value in the sense that if we were faced with exactly this scenario and kept replaying it many, many times, the average amount, the expected amount that we'd have in our briefcase is $281,500. Or in other words, if we kept saying no deal until the bitter end and ended up going home with the amount in our briefcase, it would always be one of these 4 amounts, but on average it would be $281,500. That's if we kept playing many, many times. What does this computation tell us about the amount the banker will offer us to quit? Well, presumably the banker will offer us less than this amount. It's in the banker's interest in the long run if we accept a smaller amount than this. Before going on to the next video, answer the following questions. Suppose that at this stage you tell the banker, no deal, and you keep playing. The next briefcase to be opened contains $1,000. In light of this information that $1,000 has been taken out of contention, what is the new expected value of the amount in your briefcase? And what does this tell you about the amount the banker will offer next? And then, a partly mathematical and partly personal question, if the banker offers you $250,000, would you accept it?